Welcome my dear students. So I am your Arka Sir. So I have come with a new episode on a new topic, okay, for especially for class 9 students, okay, CBSE class 9 students, but it is applicable for the lower classes also, class 7 and 8. These topics are also there, but I will cover all the content of class 9, clear. Then I will cover related to this, I will cover the content of class 11 also, clear. Now first let us start from the basic thing so that you can understand it properly, okay. So today my the chapter 2 in CBSE syllabus, it is chapter, okay, chapter 2 physics, okay, chapter 2 force and laws of motion, that is there in chapter 2 physics class 9 syllabus in CBSE, okay. Now the basic thing I will discuss today, clear, basic but very important, clear. It is required, okay, when you will go to class 11 or you will appear for the joint entrance examination, okay. The basic concept is very much required, okay. Now see, let us start the chapter without further delay. So if you have not subscribed my channel yet, subscribe it as early as possible, clear. Click on the bell icon so that you can get all the notification, as well as don't forget to share it among your friend circles or among your friends, clear. Now let us start. First, before we start the chapter, we have to understand, just for your understanding, what is known as state of rest and state of motion, clear. What is known as state of rest and state of motion, clear. What is known as state of rest and state of motion? Suppose this is what? This is the marker, okay, or this is the whiteboard, clear. So if I keep this whiteboard over here, then what will happen? Suppose no one is applying anything, no one is shifting the board from this place to other place, clear. Or if I keep the marker over here, okay, then what will happen? Suppose no one is taking the marker from here, then what? It will remain in the same position with respect to its surroundings. This is very important. What does it mean with respect to its surroundings? Surroundings mean the surroundings is what is there. The surrounding, I am here, okay, the board is here, okay, this scenario is here. So it will not change its position with respect to its surroundings. Then this is known as the state of rest, clear. But if we see the earth is moving, clear, if we see from outside the earth, okay, then what we can see? We can see this object is also moving with earth. So actually it is not rest, clear, but with respect to the surrounding, its position is not changing, clear. It is remaining in the same position. So that is why this is known as the state of rest, okay. So what is known as the state of rest? Okay, when an object does not change its position with respect to its surroundings, then the object is said to be at rest, okay. Then the object is said to be at rest. So hope you have understood this. When the object is said to be at rest, when there is no change in position of the object with respect to its surroundings in time, clear. Then what will happen? The object is said to be said to be at rest respect to its surroundings in a time. You can write this, okay. Then in a time, okay, then the object is said to be at rest, okay. So that is what the rest. What is state of motion, clear. Suppose cricket ball is moving, clear, moving on the ground. A car is moving from one place to other place, or I am walking from one place to other place. That means what? Every time, in every moment, my position is changing with time and with respect to its surroundings, clear. That object is known as a state of motion, clear. So it is known as state of rest and state of motion. That means the position of the object is changing, okay, with time with respect to its surroundings. So that is known as state of motion. So what is the state of motion? What is state of motion? When an object changes its position with time with respect to its surroundings, then the object is said to be in motion. You can write this answer, clear, in your copy, clear. When the object is said to be in motion, when an object changes its position with time with respect to its surroundings, then the object is said to be in motion. Clear. So this is the object which is said to be at rest, and this is the object which is said to be in motion. Clear. So I hope these two things you have understood. Clear. Now let us now discuss about the force. Okay. So after discussing the force, how many type of forces are there, basically that I will discuss, and then we will move to the Newton's law of motion. Okay. Newton's law of motion. Clear. So the main part of the chapter. Okay. So this is the basic concept I have given. Okay, because this concept is required to understand the later part of the chapter. Okay. Now the thing is that what is force? What is force? Clear. What is force? See, suppose a cricket ball is moving on the ground. Clear. Suppose a fielder is there, and what will happen? The fielder will apply something to stop the ball. Clear. With the hand or with the legs or whatever. Clear. Or the football player is or the goalkeeper, if someone hit the ball, okay, the goalkeeper try to stop the ball by applying something, okay, to the ball. Clear. So that part is known as force, but it does not mean that always we will be successful. Clear. Suppose a train is coming, okay, any person want to stop the train, okay, by applying the force, okay, it cannot be done. Clear. Suppose the wall is there, and I am applying a force on the wall. Clear. The wall cannot be shifted. Clear. The wall will be at rest condition. Okay, even if I am applying something on it, what I am applying? I am applying nothing but the force. Okay. So what is force actually? The force is, okay, the force is the thing which if we apply on a body, then we can change the state of the body. That means body which is at rest can be in motion, or the body which is in motion can be in at rest. Clear. Or we can try to change its state. Clear. So that is known as force. Okay. So what is force? Force is the external thing. If we apply it on a body, then we can change the state of the body, or we can try to change the state of the body. Clear. So that is known as force. Okay. So that is this definition you have to write. That means what? It is not sure that if we apply the force on a body, we can change its state. Clear. If we apply a force on the wall is at rest, the wall will not be in moving condition, it will be at rest. That means we cannot make to change its state. Clear. So suppose a moving train is going, if we apply a force, the train will be in moving condition, it cannot be stopped by applying a force by a normal human being. Clear. So it will move. That means we cannot change the state. Clear. Even if a ball is moving, the ball is moving means the ball is in motion. Clear. So if we can easily apply the force against the motion of the ball, and the ball will what? Will stop. That means we are changing the state of the ball. It was in the motion condition. Now after applying the force, it will be in state at rest condition. Clear. That means we are changing the state of the ball. Clear. So that means what? That is known as the force. Okay. So what is the force? Definition: the external thing which can change the state of an object that is when, that is if the object is at rest, then it will be in motion, or if the object is at motion, then it will be at rest. Okay, or what, the external thing which can change the state of an object, okay, or try to change the state of an object when applied on it is known as force. Clear? Is known as force. Okay, so that is the exact definition of force. Okay, so if this comes, what do you mean by force? You have to write this. Clear? So the external thing which can change the state of an object, if the object is at rest, then it will be in motion, or if the object is at motion, then it will be at rest. Okay, or try to change the state of an object when applied on it is known as force. Clear? So this will be the definition of force. Clear to all of you? So what is the definition of force? You can write it down. Clear? So I hope you have understood that, the definition of force. Clear? Now always remember, if we want an object, okay, so there are basically balanced and unbalanced force. The two terms you have to understand, what is balanced and unbalanced force, okay, and what is the use of it, what is balanced force. Okay, so the equilibrium condition that you will learn in the higher classes. What is equilibrium, okay, condition, okay, so that you will learn in the upper classes. First you have to learn the concept balanced force. Okay, what is balanced force? Suppose this is an object, suppose this is a force F that is applied from A to B, and another force, suppose that is also F, it is applied from B to A. Clear? So that means what will happen, okay, suppose this is the marker, so I am applying a force from this side, and I am applying the equal force from this side. The two forces are equal and opposite, then what will happen, the marker will not move to any direction. Clear? Because two forces will act, okay, in opposite direction and have same value. Clear? So that is known as the balanced force. Okay, so the resultant force will be, if their the value is equal and they are working on the opposite direction, then the resultant force of this object on this object will be 0. That means the object will be at rest only. Okay, it will not move in any direction. So it is known as the balanced force. Okay, and what is unbalanced force? Unbalanced force, suppose this is the object, suppose it is 2F and it is F. That means what? From A to B, the 2F, the amount of force is 2F, and from B to A, the amount of force is F. Suppose this side we are applying more force, and this side we are applying less force. So what will happen? The object, as a result, the object will move to this position. Here the object will ultimately move to this direction, because here we are pushing the object with more force than this. Clear? So it cannot oppose the total force. Okay, because it is double amount of force, twice F, and it is only F. That's why the resultant displacement of the object will be to this direction. Clear? So that means what? When the object is in motion by the influence of any force, that force should be an unbalanced force. Clear? Balanced force cannot create any uniform motion of any object. Clear? So the object, when the object has an uniform motion, the object is moving to any direction. That means what? With the influence of any force, that force should be unbalanced force. Clear? So due to the application of the unbalanced force, the object is moving, clear, to a particular direction. So I hope that the concept of balanced and unbalanced force, okay, is clear to you. Okay. Now the type of force actually are there. How many type of forces are there? And then I will teach you the unit of force and their definition. Okay. In CGS and SI system. Okay. So the type of force, types of force. Okay. So type of force, there are basically two type of forces are there. Okay. One is known as the contact force, another one is known as non-contact force. By the name you can understand, very easy. Okay. In the lower classes also it is there. Okay. So what is the example of contact force? Means by the name you can understand, contact force means when the force is applied on a body, and to apply the force we have to contact. Okay. There is a contact, okay, with that body. Clear? So that type of force is known as contact force. Okay. What is the contact force? Good example, frictional force. Clear? Frictional force. What is frictional force? If a body tries to move over another surface, clear, then what will happen? Against the motion of the body, opposite directional force will act in between the two surface of the common surface of the body. Clear? So that is known as a frictional force. Separate chapter is there on frictional force. Okay, we will also learn that later on. Okay, so frictional force is an example of the contact force. Clear? Suppose push and pull. Suppose I am pushing the whiteboard. Clear? In that case I have to touch the board to apply the force. Clear? So push and pull. Suppose I am pulling. Clear? I am pulling something. I am pulling a rope. In that case I have to hold the rope tight and then I can pull. Clear? So that means what? I have to touch the object. Clear? To apply the force. So these forces are known as contact force. So push or pull. Okay. So I can push or pull up an object. Clear? So these are known as the contact force. That means what? Here to apply the force I have to touch the object. Okay, the muscular force. Clear? The muscular force, okay, is also an example of the contact force. Clear? Now non-contact force. What is non-contact force? Here the force will be applied without touching. Clear? How? The gravitational force. Okay, if we have a piece of stone, if we throw it up, then what will happen? After some time it will fall down. Why? Because the earth is pulling towards its center. Okay, that is what? Due to gravity it will come down. So that is gravitational force. The earth is so no contact is required. Clear? So that is known as the non-contact. So gravitational force is an example of non-contact force. So gravitational force. Okay. Gravitational force is an example of non-contact force. Okay. Again what? Magnetic force. Magnetic force. Clear? Magnetic force. Suppose a piece of iron. Clear? Suppose it is a piece of iron and it is kept near the magnet. Then what will happen? The magnet will attract it. Okay, without touching. Clear? So a force will be applied. So that is magnetic force is an example of non-contact force. Clear? Electromagnetic force is also an example of the non-contact force. Clear? So these are the type of force, contact and non-contact. Very easy. Okay. So I hope you have understood this. Okay, the examples of contact force and non-contact force. Now let us discuss about the unit of force. Clear? Let us discuss about the unit of force. Okay. So what is the unit of force? Clear? And after this we will go to the Newton's first law of motion. Okay. So here unit of force. Unit of force. Okay. In CGS system, the unit of force is dyne. Okay. In SI system, the unit of force is Newton. Clear? The unit of force is Newton. Okay. The CGS system, the unit of force is dyne. So what is dyne? Okay. What is dyne? Clear? The unit of force is dyne, and in SI system the unit of force is Newton. Clear? So if the mass of a body is 1 gram, then the unbalanced force. If the mass of a body is 1 gram, then the unbalanced force which is applied on that body to generate an acceleration of 1 centimeter per second square is known as 1 dyne. Clear? So 1 dyne is equal to 1 gram into 1 centimeter per second square. Clear? So this is the definition of dyne. Okay. So many students actually cannot write the proper definition of dyne. Clear? Suppose this is the in CGS system. What is the unit of mass? Gram. Clear? So and what is the unit of acceleration? Centimeter per second square. Acceleration I will teach. Okay. The unit of acceleration is centimeter per second square. When I will teach Newton's second law, then I will teach the acceleration. Okay. So the suppose the mass of the body is 1 gram and an unbalanced force is applied to generate the acceleration of the body of 1 centimeter per second square. The increase of rate of increase of velocity of a body is known as acceleration. Clear? So suppose the mass of the body is 1 gram. Clear? Suppose this is the body, okay, or object. The mass is what? 1 gram, and the force F is applied on it, and the acceleration is 1 centimeter per second square. Okay. So this F is known as 1 dyne. Clear? This force which is required to generate acceleration of 1 centimeter per second square. If the mass of the body is 1 gram, then this force is known as 1 dyne. Clear? So 1 dyne is equal to 1 gram into 1 centimeter per second square. Okay, it is very easy. Clear? Hope you have understood this. Now let us come to the definition of Newton. Okay, definition of Newton. So what is the SI unit? In SI system, the unit of force is Newton. Clear? So unit of force is Newton. So what is the definition of Newton? Okay, what is the definition of Newton? If the mass of a body is 1, it will be what? Kilogram. Then the unbalanced force required to generate an acceleration of 1 meter per second square is known as 1 Newton. 1 Newton. Therefore 1 Newton is equal to 1 kilogram into 1 meter per second square. Okay. So this is known as 1 Newton. So now the same thing, if this is the body, the mass of the body is 1 kilogram and the force F dash is applied to generate acceleration 1 meter per second square. Clear? So this F dash is known as 1 Newton. Clear? This F dash is known as 1 Newton. That means what? If the mass of the body is 1 kilogram and the unbalanced force required to apply on it so that the acceleration produced in the body is 1 meter per second square, then the force which is applying on the body is known as 1 Newton. Clear? So hope students you have understood up to this. Clear? Now let us move to the relation between the dyne and Newton. So now the last topic of today's episode, we have learned the definition of force, contact force, non-contact force. Okay, examples of contact and non-contact force. What is balanced and what is imbalanced force? Okay, clear? Now the thing is that relation between, very important, between dyne and Newton. Newton. Okay, relation between dyne and Newton. Clear? So, relation between dyne and Newton. So, 1 Newton is equal to what we know? 1 kilogram into 1 meter per second square. Clear? 1 kilogram means what? 1000 gram. Okay, into 100 centimeter per second square is equal to 10 to the power 5 dyne. Clear? Gram into centimeter per second square means what? Dyne. So 1 Newton is equal to 10 to the power 5 dyne. Why 10 to the power 5? 1, 2, 3, 4, 5. 5 zeros are there. That's why 10 to the power 5 dyne. Clear? So 1 Newton is equal to 10 to the power 5 dyne. So this is the relation between Newton and dyne. Clear? So student, hope up to this you have understood it properly. There are many things. Okay, one by one everything I will upload. Clear? So in my next episode I will discuss about the first law of motion, or the Newton's first law of motion. Clear? And what we come to know from that. Okay, moment of rest, moment of inertia. Clear? Everything. Okay, so that we will learn in the next episode. So keep continuing to watch my episode, all the episodes. I hope it will be a very much beneficial for you. Okay, thank you.